In this video, we'll get started with using Avro schemas in our Spring Boot applications. And we have a hypothetical task to solve, which you can find under Initial Task in our Git repository, which says, as part of our streaming platform capabilities, we want to be able to analyze our users' activity. This information will be stored in a Kafka topic called user activity. Events will contain the user ID and a string that represents the user activity, for instance, logged in, payment registered, etc. We expect multiple producers and consumers in the future, so we should enforce a data contract for this topic using an Avro schema. For the first step, let's create one producer and one consumer. Now, the data model described here, we have it already in our repo represented by this user activity event.avsc file. It's got the user ID and an activity string, so we can start solving the task. Let's start with the bit we already know how to do. We'll go into Control Center and create our user activity topic. In here, we'll also add the user activity event schema. As you already know, it got assigned a schema ID. Let's move to creating our Spring Boot application now. I'll go to start.spring.io, we'll use Maven, and let's call our project schemas. We'll package it as a jar, and we'll go with Java 21, as at the time of recording is the newest LTS version. For dependencies, we'll just add Spring for Apache Kafka for now. I will take this initial project and open it in an IDE. I will be changing the application properties file to an application.yaml. This will better suit our needs for this application configuration. Next, I'll be copying the Avro schema here under Resources in a directory called Avro. Let's now try to create a Kafka producer in our application that can send Avro-encoded user activity events. Since this schema dictates the data model that our application will be operating with, it would be great to have a Java class modeled from it. To achieve this, we'll leverage a Maven build plugin called Avro Maven plugin. We'll go into the project's POM and we'll first have to define our plugin as a dependency. Then, under build, we configure our plugin usage. We'll tell it that when the generate sources stage runs, which is a Maven build stage that is executed early in the build cycle, it should take all the schemas it finds in the input directory, which we configured to be the one where we copied our user activity schema, and it should generate a Java class for each of those and place the Java classes in the build directory under the generated sources/Avro path. Finally, what we want to do is configure another Maven plugin that will also run during the generate sources phase and will register the output directory as a source directory for our project. This will make our generated Avro classes visible to the compiler and the IDE. So this way we can actually use in our code the classes that we auto-generate from schemas. To sum it up, the first plugin will generate our classes from Avro, the second plugin will make them usable in our project. All we have to do now is run a Maven clean install, and we'll see our project pop up under target/generated sources/Avro. If we go inside it, we can see we have our two fields, user ID and activity. They are even documented with doc fields that we specified in our schema. We also have another very important field here, the actual Avro schema that was used to generate our object. Also, one other thing noteworthy is that this class implements a specific record interface. Let's keep that in mind. Great, so we have the first part ready. This is the event that we want to send to our Kafka topic. Next, let's use this class in our code and set up a simple Kafka producer. We'll configure an application runner and inject a Kafka template with string type keys and user activity event type values. Spring Boot will take care to define this Kafka template bin for us. We'll write a sample event using the generated builder. And we'll invoke a Kafka template send to push this to the brokers. So what we want to achieve here is that every time the application starts, this runner will be triggered and the sample event will be sent to Kafka. But how will the serialization actually happen? If you remember from a previous video, for an Avro message to be serialized, we need to have the Avro schema that we use to serialize that message which is very conveniently stored in our Podio, and we also need to have the schema ID, the one that's set by the schema registry. Then we use both to serialize our message. So how will our Kafka producer do all this? Well, it's actually very simple. We'll go into our POM again and import the Kafka Avro Serializer Maven module. Now, this is hosted in Confluent's Maven repository, which is not included in Maven Central by default, so you need to add Confluent's repository to your POM to resolve these dependencies. So under the repositories tags, we'll configure packages.confluent.io/maven. Then we'll go into our application YAML and perform a couple of changes. We'll inform our application how to reach the schema registry. In our case, it's in our localhost at port 8081. And we'll configure our producers to use a serializer for our message values that is available in the module we imported. It's called io.confluent.kafka.serializers.kafka-avro-serializer. Now, when we run the application, our Kafka template send method will be invoked with this event. It will take this object and run it through the Kafka Avro serializer that we just configured. The serializer itself will take our Podio and retrieve the schema from it. It will go with this schema to the schema registry and say, hey, I want to write data to the user activity topic using this schema. The schema registry will confirm that the user activity topic has that schema registered and will return the schema ID. The serializer can then use the schema and the schema ID to serialize our message into Avro. It will then pass the serialized bytes back to our Kafka template, which will send them to our Kafka topic. Let's see it in action. We'll run the application. Then let's go into the control center to our topic under messages. It might take a few seconds for it to pop up. And here's our message. Another thing I want to show you is that by default, Kafka Avro Serializer will automatically register the schema we have locally in our application if it isn't registered on the topic we want to write the message to. So if we go into Control Center and create a new topic, it currently has no schema, we just created this topic. We'll modify the Kafka template call to write to the topic we just created, and we go into Application YAML and set Auto-Register Schemas to false. If we try to run this, I will get an error because we try to publish with a schema on a topic that doesn't have it. However, if we remove the auto-register schemas configuration or we set it to true, which is the default value, and we rerun this, as you can see, that goes through. And if we look into Control Center, we have our schema automatically registered there for us, and the message was successfully published. Now, about using auto-register schemas, it's obviously a very convenient setting. If you're just playing around with Kafka locally or in a development environment, it cuts the overhead of having to manually or through a separate process register schemas within the registry. And also when you pair it up with the compatibility checks that we've seen in a previous video, it's not as unsafe as it may look like at first glance. You can't just end up publishing whatever schemas by mistake, they still have to be compatible with what is already there. Still, I would think twice before allowing this kind of configuration in a production environment, because having schema registration as a completely separate and isolated process would still most likely give you tighter control over your data models, and that's what the schema registry is all about. With that being said, thanks for watching this video, I'll see you in the next one.